The most common cause for variations during a project is due to unforeseen circumstances in the ground. Take for example a highly organised project with well-resolved design priced at around $500,000. Good cost planning would allocate 7 or 8% contingency to this project, and half of this is expected to be used during the groundworks. This video identifies what risks to anticipate during groundworks, how to plan for them and avoid tapping into project contingency altogether. We'll first understand what is considered safe proximity from pipes, where pools and buildings can be positioned and have no impact on pipes, allowing simple approvals. We'll then explain how foundation design becomes more complex and expensive as foundations are moved closer to pipes, and ultimately what happens when an owner seeks to build over the top of an asset. It's important to consider these risks when building because they are difficult and expensive to address when discovered unexpectedly during construction. The best way to deal with risky infrastructure is to carry out due diligence during early planning phases, address the issue with cost-effective design, then allow the builder to anticipate and prepare for the works ahead of time. Thanks for tuning in to Design Construct, where we deep dive on topics covering design, planning, construction, and many more, helping homeowners manage their new builds better and set up for success. I'll start by showing you how to locate infrastructure in and around a block of land in Australia using a simple tool called Before You Dig. It's used by developers, engineers and contractors all the time on a day-to-day basis, and it's a free tool. Search Before You Dig, create a free account, lodge a new inquiry and search your address. If you're installing a swimming pool or a granny flat, draw your job site and limit your area accordingly. If you're building a house that will affect most of the site, choose Use Address as Job Site. Select design and planning, enter any date, make it a private application, then lodge the inquiry and wait up to 24 hours. But usually it just takes moments. All the utility providers with assets in the vicinity are tasked with fetching their network maps. In this case we have Blacktown Council, Gemina Gas, Sydney Water and so on. Each utility will automatically dispatch an email to you with their network map attached. It's an awesome web tool. Let's start with the Water Authority map. The water main is shown in blue. It's 100mm in diameter, 2.9 meters deep and located in the road reserve. The sewer main is shown orange. It's 150mm in diameter, 2 meters deep and located at the rear of these lots. The little lines represent the property connection point and indicate the direction of the flow, and the distance here is meters to the nearest maintenance shaft downstream. This dimension is handy when digging in the future to find the connection point. The squares represent maintenance shafts that typically occur at each bend in the network. IS stands for inspection shaft. So I'll trace the lot in CAD, apply typical front, side and rear building setbacks and place a single level detached home of about 230 square meters. Now I'll trace the sewer line. I'll add a 2 meter offset equal to the depth of the pipe set out from the edge of the pipe. I'll add 1 meter offset from the side boundary, which is a requirement of complying development. When building swimming pools in New South Wales, complying development is a popular planning pathway, and I have more videos on this topic in my channel. So the easiest approval pathway would be to locate the pool at least 2 meters from the pipe. If the pipe was 3 meters deep, then 3 meters away, and so on. This is safe proximity where no extra load would be imposed on the pipe. Water Authority building plan approval would be forthcoming. Now clearly the pool is conflicting with the building and the owner would seek to move the pool back towards the pipe. As the pool is moved closer to the pipe, the foundation would now need to be reviewed by a water services coordinator. Think of them as an agent on behalf of the Water Authority. So if you are building within the 2 meter offset, you will attract additional costs for a surveyor to verify the location of the pipe, the structural engineer's fees to document the pipe and design the pool and footing accordingly, and fees for the water service coordinator who would facilitate approval on behalf of the Water Authority. And plus there will be additional fees for excavation, concrete and reinforcement to build the deeper foundation. When building within the pipe's zone of influence, any footings must remain at least 600mm from the edge of the pipe. This minimum gap, along with a raft of other rules, are set out in the technical guidelines for building over or adjacent to pipes. Now the third option is when building over the top of a pipe. In order to gain this approval, the pipe would need to be encased in concrete so it becomes stronger and maintenance free in the future. This option would attract similar consultant fees as the prior option, plus costs for excavating around the pipe using non-destructive digging techniques, which can be slow and more expensive, than concrete encasing, backfill compaction and so on. Furthermore, this work needs to be carried out by an accredited contractor because we are working directly with the Water Authority's asset, and they will generally charge a premium as they are in high demand. Okay, so let's assume the owner of this lot proposes a new rear extension. You first need to commission a sewer peg-out survey by an accredited surveyor, who will survey the adjoining shaft locations and their height relative to Australian height datum. AHD is the number of metres above sea level. They'll measure the pipe invert level, which is the level of the top of the pipe, and will check the diameter of the pipe also. This report might cost $800 to $1,500 depending on the complexity, and it could take a few weeks. This information is given to the architect and structural engineer who will document the pipe's position relative to the development site. You may already have a general site survey that surveys boundaries, buildings, trees, poles, utility pit lids and the like, but site surveys typically do not lift the lids and inspect inside shaft. Section drawings are then prepared at critical locations along the pipe. In this example, we'll cut a section where the new building is closest to the pipe and also through the existing building. The pipe's zone of influence is plotted at 45 degrees. The zone of influence is the zone where loads would spread onto the pipe. This design proposes a slab on piled foundation, which requires deeper footings to support the weight of the slab, and they would pass through and below the zone of influence. The Water Services Coordinator will need to see the plans and sections of this foundation design, demonstrating that the pipe is not impacting before approving the building plan. During construction, the Water Services Coordinator will need to witness the actual depth of the piles as they are constructed to validate that the pipe was indeed driven to the intended depth. Often, pile depths will change during construction because rock and stiffer material is encountered, providing sufficient bearing capacity, and the geotechnical engineer is able to approve a more shallow footing that can save a lot of money. Now, if the proposed extension was lightweight construction, say a weatherboard cottage supported on brick piers on shallow pads, which is one of the more cost-effective foundation systems, this design would be reconsidered using a deeper foundation. Let's cut a section where the pipe travels under the house. In this example, the engineer would verify in their design statement that no additional load is being imposed on the existing footings, therefore no protection to the pipe would be warranted. There you have it, folks. Thanks for tuning in to Design Construct. Be sure to hit the like and the subscribe button, and if you're interested in finding out how big you can build on your lot, check out this movie. See you at the next one.